Section 6.4, Logarithmic Functions. This is video part 2. The objectives for this video is going to be to determine the domain of a logarithmic function and then to graph logarithmic functions, and we'll talk about the properties of the graph of those functions as well. Alright, so remember when we talked about one-to-one functions, we said that they all have to have an inverse, and we said that the domain of the inverse was the range of the function, and then the range of the function, the range of the inverse was the domain of the function. With our log and our exponential functions, basically all this means is the domain of the log function is equal to the range of the exponential, which the range of an exponential function, like we talked about in 6.3, is 0 to infinity. Also, the range of the log function is the same thing as the domain of the exponential function. So like we talked about last section, the domain of the exponential function is all real numbers, so negative infinity to infinity. So when we're dealing with the log function, so I have it up there in purple, but I'm going to write down the domain of the log function is the range of the exponential, so in this case it's just 0 to infinity. And then the range of the log function is the domain of the exponential, or all real numbers, negative infinity to infinity. Example 5 has us finding the domain of a log function. So our first example, we have f of x equals log base 2 of x plus 3. When we're finding the domain of these log functions, all we really are paying attention to is, if you look at the left-hand side, my definitions over here, all we pay attention is to whatever that x is, because our x has to be greater than 0. So if we look at our function, our x is that quantity x plus 3. So we're going to say our domain is when that quantity x plus 3, we don't need that, when its quantity x plus 3 is greater than 0, or when x is greater than negative 3. So in interval notation, that means our domain is negative 3 to infinity, parentheses for both. Our next part of example 5, we have the function g of x equals log base 5 of 1 plus x over 1 minus x. So, like we did last time, we take that x piece kind of right there. So 1 plus x over 1 minus x. And we're trying to figure out when that's greater than 0. So what I did, I graphed this. So in my y equals, I did 1 plus x divided by 1 minus x. So make sure you have the parentheses like that. And then look, and then you'll see that the graph of the function, basically the graph is greater than 0. So g of x is greater than 0 when x is bigger than negative 1, but less than positive 1. So that tells us that our domain is the interval from negative 1 to positive 1. And our last part of example 5, we have the function h of x equals log to the base of 1/2 of the absolute value of x. So, here, set that absolute value piece. When is that greater than 0? Well, we know that the absolute value is greater than 0 for all x's except 0. Because remember, it has to be greater than 0, not equal 0. So that case tells us our domain is going to be from negative infinity to 0, break 0 to infinity. Alright, to graph logarithmic functions, so we know that the exponential function and the log functions are inverses of each other. So in order to graph a log function, all we have to do is graph the inverse exponential function and then reflect it over the line y equals x. So we're going to do an example. We're going to graph the function y equals log of base 2 of x. In order to do that, we're going to actually graph the line y equals 2 to the x, and then we're going to reflect it over the line y equals x. So let's start real quick and let's make an xy table for y equals 2 to the x. So let's see, when x is negative 1, it's 2 to the negative 1, which is 1/2. When x is 0, it's 2 to the 0, which is 1. When x is 1, we have 2 to the 1, or just 2. When x is 2, we have 2 squared, which is 4. And let's do when x is 3. When x is 3, we have 2 cubed, which gives us 8. So we're going to plot these points real quick. So over -1 up 1/2, over 0 up 1, over 1 up 2, over 2 up 4, and over 3 up 8. So this, it's hard to draw on here. This is the line y equals 2x. Now, the line y equals x, that goes through your origin, up 1 over 1 for your slope, up 1 over 1. So this red line right here is going to be the line y equals x. Now, in order to reflect over the line y equals x, basically this xy point that we have over here, our little xy chart, we're going to flip it. So rather than doing -1, 1/2, we're going to graph 1/2, -1, so over 1/2, down 1. We're going to graph the line 1, 0, the point 1, 0, so over 1, up 0. We're going to graph 2, 1, so over 2, up 1. We're going to graph 4, 2, so over 1, 2, over 1, 2, 3, 4, up 2. And then we're going to graph 8, 3. So over 1, 2, 3, 4, 5, 6, 7. It's going to go off this side, but up 3. So then this purple line here is going to be your function y equals log of 2x. Stay tuned for another video which will graph exponential and log functions in the TI-84 calculator. Alright, for the last part of this video, we have the properties of the log function, so of its graph. So the domain of this, we've already talked about this before, the domain, I'll change colors. Domain is going to be from 0 to infinity, whereas the range is all real numbers. The x-intercept is going to be at 1. The y-intercept, there actually is none. Your y-axis, or the line y equals 0, is your vertical asymptote. Our function is decreasing, or our graph is decreasing, if a is between 0 and 1. If it's increasing, if a is greater than 1. The graph always contains the points 1, 0, a1, and 1 over a, comma, -1. And then finally, the graph is smooth and continuous with no corners or gaps.